In this short, we will define probability theoretically and empirically. Having an understanding of probability is essential to applying machine learning and data science concepts. Classical probability says that if we have n equally likely outcomes and n are favorable, then the probability of success is equal to small n over large N, or the number of possible favorable outcomes over the total number of outcomes. As an example, let's say we have 52 playing cards, and we want to find the probability of randomly drawing a king from a shuffled deck of cards. We know there are 4 kings and a standard deck of playing cards, one for each suit. Then there are 52 total playing cards in the deck. Therefore, the probability of drawing a king is 4 over 52, which reduces to 1 over 13, which gives a probability of 0.076. To prove our theoretical probability, we can set up an experiment, and we can do this using R. Here we define a function called draws that takes the number of experiments we want to run and then the suit of the card that we're looking to pull. In this case, we'll use a king. In this function, we'll define our data set, which is a group of 52 cards, 4 of each card that's in the set, and that gives us 52 cards, and so we have 13 different cards in a set. Now, if we sample 52 times with replacement from that data set, meaning we take out a card, look at it, put it back, and we do that 52 times, we would expect that we would draw at least 4 kings from that set on average. So we can run this experiment a large amount of times to show that on average we'll get a probability that's close to our theoretical. So we can show the graphs from the result of that experiment. And what you'll see in the graphs is the probability tends to converge on average to the middle at 0.076. To prove this is the case, we can calculate the average on the last run of 100,000 runs and show that our probability is 0.077, which is close to our theoretical probability of 0.076.